welcome back. It's time to get those brain cells a-moving. All right, so we're going to go through some reviews over the next couple of weeks, and then we will be hitting STAAR. We're almost done. You're almost in high school. So let's talk about slope today. Slope is the same as unit rate, as the same as rate of change. It can be called all those words. They're talking about slope. Okay? Slope can be found using graphs, tables, and coordinate points. All right? Remember that you have a slope-intercept form of an equation. We also have a formula to find slope, and we'll go over all that. We're going to talk about slope from a graph. Okay? Slope can be found using graphs, tables, and coordinate points. It can be also found in an equation. All right? From a graph, first, if the line is going down from left to right, then the slope is negative. If the line is going up from left to right, then it's positive. Think about it this way. You read left to right. So if it's going up left to right, it's positive. If it's going down left to right, it's negative. Second, check the intervals on the sides of the graph, because in 8th grade, there is only one problem. I will guarantee they will be by ones, okay? And that's that problem where you have your similar triangles on there. Other than that, they probably won't be, the intervals will not be by ones. And not only will they not be by ones, on top of that, they might be different on the y-axis versus the x-axis. Okay, so check your intervals on the side. So first, is the line positive or negative if it's on a graph? Second, what are the intervals on this one? It's going up by 5s. Each line is worth 5, and each line going across the x-axis is worth 2. Third, count. Write. I want you to write. Rise over run. A lot of you have gotten really lazy and you've stopped writing that rise over run, okay? The rise is how much you go up. The run is how much you either go left or right. Then you have to simplify. But write those words, because the number one mistake you do is you put your run over rise. Okay, you count this way and then you count up to this way and you say, oh, okay. Well, you're going to miss it. You got one shot. Do all your strategies that you can do on every problem and make each problem count for you, okay? So those are the simple things from a graph, okay? 3 things. First, negative or positive. Second, what are the intervals? Third, write rise over run. Pick a place you can count from and count up and then over, okay? Don't ever count over and then up. All right. That's from a graph, from 2 points. Use the formula chart. Well, your formula chart is there for a reason. Slope of a line. Okay, here it is. y2 minus y1 over x2 minus x1. That's what m is. It is slope. All right? So, if you need slope of a line from there, you need to write that formula, because what happens is if this second number is a negative, you will forget to write that sign there because you don't have this. So I always say, write your line, put your subtract sign, then input your numbers. Okay? So here's an example. 2 points. x1, y1, x2, y2. Okay? So I am going to write y2 minus y1 over x2 minus x1. I want you to then immediately just write that line, put that subtract and that subtract. Then I'm going to fill it in. And I'm going to put negative 4, because that's my y2, subtract 8 over 5, subtract negative 1. Now remember, when do you use a negative sign or a subtract sign with your calculator? If it's in between 2 numbers, like right here, it is a minus sign. If it is out front, it is a negative sign. in between, and then negative. So here is a subtract and then a negative sign, okay? So here we go. Negative 4 subtract 8 gets you negative 12. You're doing it in your calculator. 5 subtract negative 1 is 6. Because remember, a negative turns this to a positive positive. But if you'd put it in your calculator, you have to put it in separately. You cannot put this all in at one time unless you're using alpha F1. Some of you do. I don't, and I don't teach it. So therefore, negative 4 subtract 8, and I get negative 4 subtract 8, and I get negative 12. Okay, just to prove my point. And then I put in 5 subtract negative 1, and I get 6. So negative 12 over 6, you always simplify. If your answer choices are in fractions, then hit math, enter, and it'll give it to you in a fraction. If it's over 1, then it's going to give you as a whole number, okay? So I'd have negative 12 divided by 6, math, enter. It'll simplify it as a fraction. If you need a decimal or a whole number, then you just hit enter, okay? If for some reason you have a coordinate point or a point in a table that is 0, I highly suggest you do not use the 0, okay? Just doesn't ever work out very well. I've never seen it where they've given you a coordinate point as a 0, but I've seen it where they've given you tables where you could use a 0, skip it, and use 2 different points, okay? Let's flip this, okay? All right, slope from a table, all right? Use the pairs in the middle of the chart. You can use any 2 pairs. It doesn't really matter. We say the middle of the chart because when you get to proportions, you'll only check 1 pair because, we're lazy mathematicians. And generally, if there's an error, there's going to be an error towards the middle. The first 2 will work because they're counting on you checking them all right? Make sure you are putting y over x. There's the number 1 mistake. We do x over y. But if you will just refer to your chart, even look at it, it has your y's over your x's, okay? 2 kinds of positioning of a table. It's either vertically positioned, where your x values are on the left, your y values are on the right, or it can be horizontally positioned. Your x's are always on top, your y's are always on the bottom, unless they tell you different. But I'm telling you, that's just the way it's going to be. So we have an example. Now, see, I know that we use this box, and you could do your y1 minus y2. You could do, these are your x's, these are your y's, so x1 minus x2 over y1 minus y2, okay? At this point, I kind of do this thing, okay? And I take the bottom one, which I do y, I write myself this, y over x. And I take my bottom one, 18, subtract my top one, which is 12, over my bottom one, which is 20, subtract 16, okay? Come over here, and I do 18 subtract 12, and I get 6. And here I do 20 subtract 16, and I get 4. 6 over 4, I'm going to simplify. 6 divided by 4, math, enter, and I get 3/2. And if I simplify that even more, let's say I wanted a fraction, I could hit 3 divided by 2. I wanted a decimal, it's 1.5. Now, the one thing I want you to realize, it's consistency, okay? If for some reason I did 12 subtract 18, let's see if it works. But my y's have to be on top. So I'm going to write y over x. And I'm going to write 12 subtract 18. Let's see if this works. As long as I do 16 subtract 20 and don't flip it the other way, 16 subtract 20, 12 subtract 18 in my calculator is negative 6. And 16 subtract 20 in my calculator is negative 4. If I divide negative 6 divided by negative 4, math, enter, I get negative I shouldn't do that. Negative 6 divided by negative 4 math. Oh, I didn't put a 6 in. That's my problem. Negative 6 divided by negative 4 math. Enter, enter. I'm having problems with my fingers today. I get positive 3 over 2, which then, if I simplify, would be 1.5. So I got the same answer, didn't I? As long as you are consistent, but y's have to be on top, okay? So order doesn't necessarily matter. It's being consistent in your order, okay? Let's talk about y-intercept. The y-intercept on a graph is the y value where the line crosses the x-axis. So right here on a graph, all it is what is the value, where is it crossing on the y-axis. So if you highlight your y-axis, you look for the point where that's crossing, the y-intercept is 2. Now, what is the x value where that line is crossing? 0. So if you're given a table, okay, the y-intercept is where x is equal to 0. So let's say I have this table right here, and I had all these numbers, my x's and my y's, and I had, let's say, negative 5, and I had 0, and I had 3, and here I had, I don't know, this won't make sense, and some of you will get upset with me and say, that doesn't work. Okay, well, it may not, but here we go. Right here, where x is 0, this is my y-intercept. Y would be equal to 5, okay? Now, if you don't have a 0 in your table, the only solution you can do is to back out until your x value is 0, and that's a whole nother skill. But some of you will be able to do that. You just back out how much it takes. So if you get that problem today in class, then ask me and I will help you with that, okay? I do want to go over one thing, so please pause it and go get your STAAR review packet. Okay, so now we've got our review packet back. I want you to turn, let's turn to number 12, okay? Alright, it says the line on the grid below shows a proportional relationship. Which scenario best matches the proportional relationship shown on the graph? So they're looking for rate, and rate is slope. Proportional means the line has to be straight, it has to go through the origin. We're going to talk about this some more. But I'm going to look at this line before I start looking at all this. I'm going to look, okay, those are going by 10s. These are going by 2s. It's going positive. I'm going to look for a place where it crosses. Let's see here. Oh, it crosses here. Next place I see it cross really is here. So I'm going to see if any of those things make any sense, because I've got 40 and 6, and I got 60 and 12. So let's see if it makes any sense. Lynn spends 40 on a dozen charms. Well, that could either mean 40 for 1, because if it's a dozen, or it could mean 40 for 12. Well, here it says 40 for 6, so there is no way that this is going to work. Okay? Every 6 months, Peter washes 30 cars. Well, if I go to 30 and go over to my line, and I come down to here, I'm not at 6. Do you see that? 30 going across and down to here. I'm not at 6. I'm more like at 5. So I don't like that one either. At a bakery, customers paid $20 for 3 pies. So $20. I go over to here, and I come down. Hey, that's right in between 2 and 4, isn't it? And if I double 20, I go to 40. If I double 3, I go to 6, don't I? So then I'd have my 40 and 6. I think I like this one. All right? And let's just double check D. $120, because there's no 120 over here, for every 12 yards. So 120 would go to here, because it comes across, and it comes down and it's at 18. So that one doesn't work either. So just be careful and look at your graphs though and see what's happening. Also, make sure you're reading the sides of your graphs because a lot of you don't do that and that's where you make your other mistake, okay? Also, remember, just because like some instances you are given like on, and I'm not going to do it for you, but like on number 7, you are given a table and they want you to match the data in the table to the graph. Sometimes the first one will match, but not the second one. So make sure you're checking more than one data point on your graph and make sure that it's actually following. And then question 8, be careful because they're wanting the slope of the line from up here. So remember that slope is for each. It's unit rate. So like here, if I was 75 for 3, remember these are your x's and these are your y's. So to find slope, you have to do y divided by x. And that's the only hint I'm going to give you because that is your unit rate. Because you want to know when x is 1. Okay? So that's why you do y divided by x to find out how much it is for each one. All right? Have a great day, and the packet's due at the end of the day.